Welcome, everyone. Thank you so much for joining us today for York Flashing's webinar. We're really excited to have you all. You have myself, Kayla, Partner Success Operations Manager from the Acelab team, and we have Megan from the York Flashing's team. So while we let everybody join in, I am going to quickly share my screen and show you where on the Acelab page you can learn more about York Flashings. So here we go. So when you first log into Acelab, you'll be brought to the home page and you'll go to the search bar, type in York Flashings, and it'll bring you to their brand page here. If you scroll down, you can learn more about the business, where they ship to, where they're located, their specialties, and then you actually have Megan's contact information right here. So you can click that if you'd like to get in touch with her. We have a few highlights. We have all of their products here for you to click into, save to your firm library if you'd like, just learn a little bit more about each of them. And we have a couple of case studies as well as some inspiration photos at the bottom. So I encourage you to check out this page. If you have the chance, I'll drop a link in the chat. So feel free to use that. And a few other things to go over before we get started. I want to make sure everybody knows about our Q&A. So you'll see at the bottom of the page a Q&A button. So you can use that to drop any questions that you have. Towards the end of the webinar, we will go through those questions. We'll also have a poll and a survey at the very end for you to take. So I encourage you to do that. Last but not least, this is a CEU approved webinar. So we did collect your AIA numbers upon registration. So we'll make sure that you get credit with that. If you're worried that you didn't share your AIA number with us yet, I will drop a form in the chat as well that you can fill out to ensure that you get credit for today's event. And that's all I've got. So I'll pass it back to you, Megan.
All right. Thank you, Kayla. I just want to confirm you are seeing the opening slide of the AIA presentation.
Yes, I can see it.
All right. Very good. Well, thanks, Kayla and the Acelab team for having York on today to present. This is our newly launched 2025 AIA presentation. I want to thank everyone for tuning in. You can find more about our products on Acelab, like Kayla just showed. I am available at any time, so my contact information is on the screen. If what you hear and see today is of interest to you, we can certainly set this up at your offices in person or virtual. We have a great team of sales reps across the country. And we also have another AIA and GBCI presentation that we offer on through-wall flashing and transition selection and installation. So that's another good follow-up program. I did present that one for Acelab back in 2024. So that's another good one if you would like more information. Like Kayla said, this is an AIA program, and we will be submitting for those credits tomorrow or Friday or early next week. Learning objectives, since it is an AIA, I want to read through these and we'll start here. So thanks again, everyone, for tuning in, and I hope you take away some good information that you can help utilize in your future projects and within your teams. So learning objectives, we're going to talk about compatibility issues between the building enclosure air barrier components. We'll look at where those areas with the highest potential for air and water issues are. We'll demonstrate the ways to reduce the risk of water and air infiltration at transition locations. So that's the big topic today. And we'll talk about how the air barrier components transition. With all that, my goal today is to emphasize how important it is to get the transitions right in the building envelope. And we're going to provide an overview of where those transitions are, the things that we have to keep in mind when we're determining what products to specify and install at these transitions. The building envelope, it's a huge topic. We'll start our introduction here. There's entire presentations and lectures on the building envelope. But today, I figure this is a good place to start rather than jumping right into the transitions. The idea here is to keep the outside out and the inside conditioned air in. In order to do that, we need to look a little bit more closely at the 4 control layers. And these are the 4 control layers around our building envelope that we want to get right. There's entire presentations on how you trace these layers. We need to understand each layer and its importance when we make decisions about what products to use here. At the end of the day, you want them all to work together, and they need to be compatible. So that's a hot topic and a concept that we'll discuss pretty thoroughly today. They need to be compatible and properly integrated. So when you look at transitions as a whole, they provide that continuity for each of these four barriers: your water, air, thermal, and vapor. The number one job is to stop water. And it's no secret that water can lead to severe damage in our walls. Ideally, we don't want any leaks, but we also want to make sure that we're providing drainage for when that water does get into our walls, it has the opportunity to get out of the wall. Number two, we need to stop air. The whole purpose of the air barrier is to reduce your airflow in and out of the building, and this is to prevent water and moisture issues. This little graphic on the screen, I think it's pretty astonishing that if you consider just a really small hole, 1 inch by 1 inch, over the course of a year, you can have 30 quarts of water get inside your building just through that 1 inch by 1 inch hole. And maybe you don't have a hole that size. If you break it down, let's say you have 4 holes that are each a 1/4 inch, it can still lead to this amount of water, which is, when you put that into perspective, it's quite a bit. The third layer here is our thermal control. A lot of people refer to this one as the building's blanket. This layer, we're not really getting into this one today. This would be your insulation materials, and the whole goal of those materials are to help maintain your indoor temperatures, reduce heat loss and gain, and just enhance your overall energy efficiency of the building. And then the fourth layer, and again, this is just a really simple overview of these layers, and they can get pretty complex. We have a lot of materials coming together. This is just kind of to open up the presentation before we get into the transitions. The fourth layer is for controlling vapor diffusion. So we saw a similar image that's on the screen now when we were looking at the controlling air slide. A lot less water than the 30 quarts of water that can result from a 1 inch by 1 inch hole, but it's still important to control the movement of our water vapor through the building envelope. So you're looking at a big red line around your building. You may have heard of this strategy before, of putting your pencil down and tracing the layers without lifting it up. The whole reason we want to do this is to make sure that we're getting that continuity across our building envelope between our systems. So you can see that red line that goes all the way around the building, there are no gaps. And some people will call this the red pen test. The whole point of this is to identify all of the locations of the components that make up those 4 layers that we just reviewed: the water, air, thermal, and vapor. So the question of continuity or compatibility comes up when we are changing from one system to the next, or we change from one product to another. And that's where we get into this whole idea of transitions. What is a transition? It's when something is changing in plane or material. So consider when you move from an air barrier to a below grade product, or from an air barrier to a roofing system. You can't just pick up your pen and restart the next system. It has to be continuous. And that's a lot easier said than done, especially when you have all these different chemistries. You have membranes coming in contact with liquids, and you have sealants and adhesives. At these locations, we introduce a transition product that needs to be able to work with those 2 systems that you're transitioning between. And I mentioned this phrase earlier: the transitions provide continuity for each of those 4 barriers: water, air, thermal, and vapor. Overall, transitions are a really small part of the building, so you might be wondering how important they really are. This is an article from the IBEC Interface magazine. It's been a couple years since this one was in there, and it states that 90% of these building enclosure failures occur in 1% of the enclosure. Well, what is that 1%? These are the issues that we have at fenestrations, so our openings in the wall, penetrations, roof to wall transitions, and dissimilar material transitions. So 90% of these failures are, even though it's in these small areas, this is where all of the issues can occur. Not all of them, but a lot of them. Now that we know what this whole concept of continuity means, we want to talk about how we actually do it. So our focus today is on controlling air, controlling water, layer number 1, layer number 2. What do we need to make these layers continuous? So we broke it down. We're going to start easy here. We have connection materials and a sound substrate. What are connection materials? Those are the transition membranes. So a self-adhered tape, a silicone sheet, and all the accessories that go with it. Your sealants, your term bars, your primers. Next, we need our sound substrate. So we need a good surface that the products will adhere to for the life of the building. And we're going to get a little bit more into that, but it's some things that are as obvious as making sure the substrate is clean and it's dry and it's solid and it's not mud and it's not water. There's a lot of materials out there that you can use for transitions. A lot of manufacturers have their own transition material products within their own system. So that's not necessarily where we might be talking about today within a manufacturer system, but we're talking about when you have to move from one manufacturer to another. So a roof to wall or your air barrier to your below grade product. When it comes to considerations for choosing transition materials, we broke it up into making sure you have compatibility between them. What are the installation musts? And then knowing your products. What are the limitations? How does the product need to be installed? And we're going to walk through each of these a little bit more in depth. This first concept here is compatibility. Compatibility, we're breaking it down into making sure things are chemically and adhesively compatible. So when they're coming in contact with each other, are they chemically compatible? Meaning they're not going to dissolve each other or cause another one not to perform as intended. This is actually a chart from the Air Barrier Association. They have a flashings and terminations committee. And this is something as simple as looking at all of these flashing products. And then going across the top, you have other construction materials that your flashings may come in contact with. There's no manufacturers listed here. So this is literally just a generic, non-proprietary. Within each one of these categories, there's multiple brand names and different types of chemistries. And even if it's a peel and stick butyl membrane, they're not all created the same. So you have different chemistries within that. This is a really good chart. I don't know if we covered this in the beginning, but if there are any slides, charts, articles throughout this that I referenced that you'd like, I am absolutely more than happy to share those with you. We use this chart here as a good start, but I highly encourage everyone to use their reps, lean on the manufacturers to write letters of compatibility between neighboring materials. We do it all the time, and it is something that we're more than happy to help you with on projects. What chemical compatibility can look like on the job site. On the left, they used a sealant that actually ate through this tape. So we got a compatibility issue there. On the right-hand side, that is a butyl adhesive membrane that was lapped onto a PVC roofing. PVC has plasticizers that can break down certain adhesives. Butyl is one of those. Had they caught this prior to installation, they could have figured this out. If you would have sequenced them differently, you wouldn't have run into this issue. Two good products, but not chemically compatible when they came in contact with each other. Another approach to compatibility is adhesive compatibility, and that is, can things stick together? Not just on the back of the product. If you're using a self-adhering membrane, people will ask, what's the adhesive? Is it some products have an acrylic, some have a butyl, some have a pressure sensitive adhesive. Not just the adhesive on the back, but what's the facer? If you're going to be overlapping other materials on top of it, is the facer a material that is a good surface for other products to bond to? And this is showing you that not all products are the same. You have a polyethylene, a cross-laminated polyethylene, essentially a plastic facer. And you can see all these test strips that were pulled up, and they pull up pretty cleanly because those liquid and sealants don't bond onto that facer very well. On the right-hand side, you have a stainless steel face product where everything is sticking on, and you see those test strips that actually broke when they tried to peel them off. What this looks like on a job site, you have a fluid air barrier. You can see it here. It's actually delaminating from the facer of the product that was used in the rough opening. And it doesn't always have to be this extreme. I mean, this is a pretty obvious adhesive compatibility issue. It might not happen initially. So we want to be mindful of the products that we're putting on top of each other, especially at these transition locations. At the end of the day, whatever you're using, it has to stick. There's a lot of great articles out there. There's some things that are obviously hard to stick to, right? Like mud and water and holes. But then there's also some things that we deal with on job sites like polyethylene that we may not realize is a facer on some products that some of our sealants don't adhere very well to without a primer. We just looked at compatibility. Next up, we're gonna look at the installation must-haves, and that is sequencing, substrate, and rolling. I want to point out on this slide, it is not a manufacturer issue. It is an installation. You want the water to be able to go downhill and have it move out and away from the wall, not go behind these materials. We have a reverse lap here. You have some fish mouth, so water can go behind these materials. Due to the sequencing on this one, that's exactly what we have. We have a reverse lap. It went unaddressed. Unsealed edges. You can pretty clearly see that this was not rolled because you see all these wrinkles on here. Maybe the manufacturer recommends a termination bar. Even high-performing products can still fail when they're installed incorrectly. And possibly that incorrect installation is because they were sequenced wrong. In addition, another note on the product sequencing, what you're seeing could also be classified as a compatibility issue. We have a rubberized asphalt flashing that was lapped on top of the PVC roofing, and you can see that those plasticizers got into that asphalt and caused it to drool. Had the PVC been reversed and gone on top, the material would not have done this. There's a roofing manufacturer that I was on a webinar a few weeks back, and they actually had a similar picture as this, and the roof was only a year old. So it doesn't have to take a long time for this product sequencing issues to present themselves. The substrate needs to be clean, fully cured, needs to be dry. Before we're installing our transitions, we need to make sure that that substrate is ready. And like I mentioned earlier, you go and you put a flashing down here on this wall. Some of this is pretty obvious, right? You got these voids here, they're filled with water, it's clearly covered in mud, gaps, wet concrete, but we need to do our housekeeping before we put these materials down. Self-adhering membranes, per manufacturer's installation instructions, they need to be rolled. So we have to hard roll this in place. Also, some require a primer, some don't. And if it does require a primer, you want to take that into account. That adds material and labor costs. That can double the installation time. I was meeting with a contractor out on the West Coast about some installations, and we brought up the topic of primer, and he said, something that we forget too is the absorption rate. And sometimes we have to even go back and reprime surfaces twice. He's like, and we really just hate doing that because of the time and then waiting for it to cure. And it's something that we didn't, if you don't account for it, this is just more time and money that are adding to the project. But you see that contractor there in the window opening, hard rolling it in place. We want the adhesive on the back of the membrane to really bite in to the substrate. And that happens a lot differently than when you hand pat it. We talked about compatibility, we talked about the installations. Now we're going to talk about the product limitations. And we need to make sure that we're using the right products in the right places. First up, we have movement. Different materials have different movement capabilities. So we need to find out if this transition is in a condition that needs to allow movement. We were contacted about a project where they were, the architect was looking for a product to use in a spa to pool transition. And the transition membrane needed to be sealed to hot applied waterproofing on one side and bare concrete on the other. The first thing we asked is this a dynamic or static joint? Because some products will stretch, right? Like they'll stretch, but they don't go back. Like a rubberized asphalt, you might be able to stretch it, but we want something that if it needs to be able to accommodate movement, it can over and over and over again without being compromised. So movement is a product capability. Spanning the gap. Rubberized asphalt membranes typically cannot span greater than 1/4 inch. And we say that and we're like, okay, that's not going to happen. And then we look how big 1/4 inch is. It's not a lot at all. So we need to know what products can and cannot span gaps. If they can't span gaps, then they need to be supported. We're looking at on parapets, through wall flashings, your air barrier. When your air barrier transitions to your through wall flashing, can that through wall flashing span a gap? And if we have to support it, then that adds material and labor costs. If we're not supporting these products, we don't want them sagging and drooping in our walls where they can end up holding moisture. Some materials don't perform well in certain environments and they might fail over time. This could be due to various reasons like corrosion, degradation, when metals are in contact with other incompatible materials. I'm going to point out this picture on the left-hand side. This is a drip edge, and you can see that it's rusting. This project was not even completed yet. One of the unfortunate realities with this is that in order to replace it, you have to tear down some of the wall. And think about when these materials are not easily accessible, it adds to the importance of getting them right the first time, because these fixes can be pretty darn costly. On this, you're seeing a lot of asphalt goo on the slide. These products were once embedded in the wall, and now they've melted out. If these transitions are in areas where there's going to be a lot of heat, keep in mind membranes can melt, and transition membranes are no exception to that. So how hot are the environments, or how hot can these membranes last? It really just depends on the product. Self-adhering products have different flow temperatures, and you can see there's a breakdown of this, give or take some variation. You can see your butyls and acrylics have some higher melting points there. So you have to know, what's the condition that the product's going to be in? Is it a roof to wall transition? Is it going to be under a rigid metal flashing at a parapet? Is it a through wall flashing that will be connected to a rigid stainless steel drip edge? And that can really heat up the membranes, and because they're exposed to the sun, those stainless steel pieces. The last product, the product characteristic that we have is UV. And UV exposure or lack of UV exposure can really compromise these materials out on the job site. These snippets that you're seeing on the screen are from different manufacturers' transition membranes. And you can see they vary quite a bit. 60, 12 months, 180 days, 90 days. We might not always expect these products to be exposed for as long as they are, but we all know what can happen with material delays, weather, different scopes coming in at different times. We need to know the UV limitation, and proper or improper sequencing can really play into the compromising the integrity of these materials. We just reviewed all the considerations. Remember that statement from IBEC, 90% of building enclosure failures happen in 1% of the enclosure. We have a lot of complex walls and assemblies, a lot of things coming together. We need those transitions to provide continuity. Building science tells us how important these transitions are. We have modeling that we do now. We have air testing and advances in all of that that really show that these little transition areas can cause a lot of issues with our building performance. We don't want those transitions to be the weak link, and we need to know where they are before we can make sure they're correct. So where are they? Well, they're where we put all the holes in the wall. You see the red circles here. So we got a lot on this one. They're not only where we put holes in the wall, but they're also when we transition from one system to another. So you combine those two building renderings and the transitions are everywhere. What that might look like, here's a real life example. A lot of products coming together. We have different cladding materials. We have a lot of windows on this building. We just have to make sure that we're putting these products in the right place to win and giving them the best chance to perform the way that we want them to. Hopefully at this point, you understand the importance of transitions, things to keep in mind when we're selecting these different materials. We need to, there's a ton of different materials out there. The manufacturer's installation instructions, the compatibility and the sequencing all play in when we're providing these project-specific details. We're going to look at these next handful of slides that I have at some of the specific areas where these transitions occur, and maybe some ideas that can help you on future projects tackle these situations or tackle these transitions that come up. The first one is below grade waterproofing to the air barrier. So before we talk about the transition, a few basics about below grade. It can't be exposed to the exterior and it needs to be continuous. So we need to make sure that the below grade transitions to the air barrier. And you can do that in many different ways. It needs to be installed correctly because it's not exposed. That's the whole point. So we don't see it when the building is finished. But when there's a water intrusion issue, it costs a lot to fix it because we can't easily get to it. So here is an example. This was a project where they needed to transition to below grade. They used a flexible metal transition here to wrap this slab edge and onto the below grade. They tooled a rather large bead of sealant there. That's what that blue is. That's sealing all of the edges, the seams there. In this installation, they used a product with a facer that can withstand a lot of different conditions. One issue at this location is exposure to chemicals post-construction, which can really break down the facers on these materials. Sometimes we forget about that issue. But you also have a product that has a really high UV resistance. Remember this facer, that compatibility, the whole idea of making sure that things can adhere to it. You have bare stainless steel. Some membranes might require a primer when you're applying them. So that is something to take into account at this location as well. When we specify or detail a transition membrane, there's a few things to check for. So you got the list here. Compatibility, chemical or adhesive. Does the substrate need a primer before applying the transition? Check the cure times before we put something else on top of it. Some products say that they need to be cured, the concrete needs to be cured for 14 days. If things aren't fully cured, they can continue to off-gas, and that can cause delamination when we're putting products on top of it. The sequence of installation, this goes hand in hand with compatibility and the ability of materials to lap on top of each other. We also want to make sure that we have all those accessories that you need, termination bars, edge sealants, and then protection, covering up the product to limit exposure. And in this picture, they actually left off the protection of the membrane. That membrane can't be exposed forever. And we don't have a complete transition. So, at first glance, I think it looks okay, but there's actually no transition to that air barrier. The next location is a transition between different air barriers. We started talking about this a few years ago, and it was definitely a lesser known application. Like, why would you use two different air barriers on a project? Now, it's not so much a foreign concept. This is a picture on the right-hand side. It's an aquatics facility, and you can see right in the corner that small sliver of an air barrier or of an area where they could not bring those two air barriers together. They needed something to transition those two together to provide that continuity and prevent them from coming in contact with each other. Like a lot of details out there, there's multiple acceptable ways of doing things. Here's an example of one. It was correct, but maybe a little more complicated than it needed to be. This was the neat detail. It was put together by an architect, and they had two different liquid applied air barriers that needed to be transitioned, but they were not compatible. So you have A and you have B. And you can see what they did there is they had put a piece of rigid metal flashing between those two, and then they used different tapes, each air barrier's flashing tape on top of it. You have a lot of layers here and a lot of things to work out with who's coming back to install certain parts of this. Did it work? Yes. Can we provide a little bit of an easy button? This is what could have happened for the same application in the slide prior. Two different air barriers that needed to transition. We can simplify it and use a product that everything is compatible with. Obviously, there was a couple steps that were reduced here. What does that mean? It means we're saving money, we're saving labor. Same condition, but one was quite a bit easier. Another example of what we just looked at, you want to make sure you're testing everything. You're looking at things from the chemical side of things, adhesive, testing things in both directions. They had a blue air barrier and a green air barrier, not literally, but just for the sake of this detail, they needed to transition those with a membrane that was compatible with both. It's not the only way that you can do this, but it worked well for them on this project installation. The roof to wall, this is another big transition area. Some of the largest holes in the air barrier system are found here, and more specifically at the parapet. We can't have gaps. So this is, you'd be surprised at how many times this happens, and you'll notice this. First thing is we need to identify where the roof air barrier even is, what it is, and how it's connected to the wall. You can see this wooden deck up here where the roof membrane, it's not connected to the air barrier. Who's responsible for that? Possibly this was something that wasn't discussed during a pre-construction meeting, or maybe there wasn't a pre-construction meeting. I'm not sure what the details, this was us just driving by this job site and seeing this. I'm not sure what the details look like, but we can certainly see that there was a gap that was missed here. And if you think of that red pen test, they stopped it and then they picked it back up to start that roofing. The crazy part about this is that this picture on the left is right near that building that was on that previous slide. We have another roof to wall connection that was missed. It needs to be continuous on the right. You can see that they did a transition. That black is a fluid applied. They didn't use a membrane here on the underside of this horizontal due to some product limitations. I don't know what the rest of the construction looked like on this one, but we need to make sure that we're completely sealing and transitioning this. No obvious big gaps at that roof to wall connection. So the issue here is there's a lot of roof systems out there, and they're limited to the types of products that they can transition to. And there's a lot of different formulas. So we have a lot of different chemistries going on. So what is that compatibility between the roofing system and the wall air barrier system? It needs to be it needs to be detailed with this is in mind. And if you need to have a separate transition membrane incorporated, you gotta, backtrack through the presentation and take into all of these things into account when you're selecting what material to use. I do want to shout out the Air Barrier Association. They have a set of roof-to-wall details and guidelines that are expected to be available sometime in this quarter. They've been working with the consultant to do these in 2D and 3D. When you're looking at this roof-to-wall transition, obviously the sequencing of trades, who's coming in at what time, are there membranes that are compatible in both ways? Maybe you put the membrane down first and then you do the roof and the wall transition on top of it. And if you have to flip that due to sequencing, make sure you're choosing something that is still compatible. The longevity, if you're using, I haven't really talked about this one yet. It's just that whole mindset that whatever you're using to transition two materials together, make sure it can outlast the two products you're bringing together. You don't want the transition to be the weak link. On this detail here, you can see that you have two different products, a wall, a roof material system that needed to come together. They put down this product here first, and that way you can now make that transition. You do the red pen test, you bring it up, and there's no gap. You're not stopping and connecting to the air barrier. It's continuous all the way up that wall. This isn't roof to wall, but top of wall. We want to make sure that the top of wall is protected during the installation of the air barrier. What we really mean by that is seal off the top of the wall. And the recommendation here is that use a self-adhered membrane. This is the ABA, again, a position paper by them. The top of the wall, you don't want to put the air barrier on the wall on a Friday and then come back on a Monday to continue working and you got a couple inches of rain throughout the weekend. So that self-adhered membrane at the top of the wall can be used to dry in your building using a material that's durable, UV resistant, and then compatible with whatever is going on the wall. You don't have to come back and remove it. And you can see, you might be wondering how big of an issue could this be? Well, you see in these pictures, and I know they're probably small, but you can see a fluid applied membrane that's delaminating, debonding from the wall. And it's not a rare occasion. This happens. Through wall flashings, we have another transition here. We're a little biased at York. This is one of our favorites. I mentioned early on, but if you joined in late, we do have another presentation on through wall flashing, selection and installation that walks you through all the flashing materials on the market, the advantages of those, and best practices for installation. And that's a good program. We get a lot of good feedback on that one. But through wall flashings are part of the building envelope, and your air barrier has to integrate it with it. So when it comes to flashings, couple just the whole point of flashing, collect the water, get it out of the wall. Flashing does a couple different things, and that's, where it's located. It can prevent rising damp. It protects our structural steel at our shelf angles. It's important that when we integrate this with our air barrier, it's compatible. So something as simple as this little bead of sealant at the top of our termination bar, is it compatible with our air barrier on the wall? So that this flashing, people will call it that little line on the bottom of the drawing. It's so critical to make sure that we're getting the water that gets into the wall, out of the wall. It's kind of like that last line of defense, and it is not to be overlooked in our building envelope. The last location we're going to look at are the fenestration to wall transitions. We have lots of openings on our buildings, lots of opportunities to get it wrong. Where are the fenestrations in our walls? We're talking about all the holes in the wall. So if you take a quick look at this building, if the transition is missed here, we have plenty of areas where this building can leak. As with all the transitions we talked about, we need that continuity. You can do transitions at this fenestration to wall with a sealant or a membrane. When you're selecting a sealant or a membrane, you want to take into how big is that gap, that difference in plane between your window and your opening, what type of movement is going to be taking place there, and the substrate, making sure that that substrate is ready for the material, and is it compatible with what we're putting on top of it. Using a membrane is one way of doing this. I want to point out this red dotted line here. So that's what you're drawing your attention to. If you're using a membrane, really the only membrane that would apply here would be those pre-cured silicone sheets. And I'm going to have to defer to a manufacturer that makes those. They allow movement. They can stretch with the building movement. So that's really the only membrane that you would want to tie into this curtain wall transition. There are other membranes out there, rubberized asphalts, the flexible stainless steel. Sure, the flexible stainless steel is durable, but it doesn't stretch. And remember, we not only want the membrane to be able to stretch, but we want it to be able to allow movement over and over again. And when you start to build up the layers of membranes in these applications, like you see over here, it's just something that you don't want taking place there. The other type of transition would be a sealant transition. And again, we're looking at a curtain wall. That blue arrow is the primary air control sealant for the curtain wall. And it needs to be in contact with the transition membrane that's going into the rough opening. And that is that red dotted line. But there's a little bit of a conundrum here, because some manufacturers' facers on that, let's say that red dotted line, some facers are only compatible with their own sealant. But the curtain wall manufacturer may require their sealant to be used with their curtain wall installation. So it leaves you in a little bit of a dilemma. What do you use? Well, you need a transition that's compatible with all sealants. The left is an example, that orange arrow up there. We have a polyethylene faced membrane. They used a silicone sealant directly to the face of that polyethylene. Silicone doesn't stick to polyethylene, and this building more than likely will have an issue there. The top right, similar situation, similar condition. That is a bare stainless steel flexible membrane, and you won't have any issue with the silicone sealant going directly to that face. Switching gears really fast before I wrap up here, I'm going to show you guys excuse me, something pretty cool for attaching or flashing at your storefront windows. This is a detail that we often see it drawn up like this, and you can see how that flashing is just really designed, detailed underneath of that storefront window. This is hard to build. If we need to put that flashing in, it's before the window goes in, and then we're left to work around that flashing when we're doing the insulation and the veneer. And this bead of sealant here really should be going to the air barrier. I'm going to give you all a solution. It's a two-piece system. It's a receiver and a clip. And all you're doing is moving that attachment point of your flashing. I'm not telling you that you need flashing. You already need that. I'm just showing you a way of attaching it. So rather than in your sill, you're going to be attaching it to the front face of the wall. And this is what you would do. You would do your air barrier, your water, your rough opening detail the way you normally would. You put a bead of sealant in. This is where the product comes in. It's a receiver that goes onto the front face, that vertical face of the wall. Then you would put in your perimeter seals and your fenestration. So at this point, your building is dried in. And you have that circled area where your perimeter seal is coming in contact with the air barrier. It's not being interrupted by a piece of flashing. Now you can put in the insulation and the cladding, whatever that is. It does not have to just be masonry. And you don't have to worry about working around a piece of flashing hanging out of the wall that you could get damaged, and more importantly, damage that perimeter seal. Lastly, you have the piece of flashing that clips into place, and then you'll seal all of the edges there. So this is just a method of attaching that fenestration perimeter flashing. Benefits: mitigates thermal bridging. You don't have your flashing running underneath of that window anymore. It's flexible, so you don't have to put in your flashing before the window goes in, because the building is going to be dried in without the installation of your flashing. You're not interrupting your primary seals. You're not going to be fastening that flashing in your rough opening. So you don't want to be putting fasteners in this rough opening because you need to attach your flashing somehow. And then replacing the flashing is pretty easy, because you just pull out this clip and you put a new piece in. And I'm going to show you a really quick video here on, I forgot I actually did have a video. That's the receiver piece. You can see how the pieces start to fit together here. The last piece that comes in will be your flashing clipping in place, which gives you all the advantages that we just talked about. So while we're talking about our fenestrations, thought it'd be a good time to put this in here. Here's a project in the southeast part of the country. They have the receiver in, the picture on the left. The receiver is in place. The wall is not finished. The picture on the right, they're coming back and they're just clipping that flashing into that receiver. So that flashing you already need, this is just a method for attaching it. And here's another one. You can really see how the aesthetics go with this really, really small sliver. This is the product. It's a really little piece of metal there of the clip that you see. And this is the flashing that was clipped into place. All right, so I'm going to wrap up here. So we're coming down the home stretch. We talked about the importance of transitions, things to consider for the material selection side of things, where the transitions go. Just a couple wrap-up points from the presentation, where we go from here and what else we can do. Specifying the right products and detailing it. This is on the screen is an example from a project. It was a transition detail. It was missed in the construction documents. This project later on brought in a consultant. This one detail required 3 different trades to coordinate together and execute it. So like the slide says, if you don't detail it, it will not happen in the field. These small little transition areas are really important, because it's, you know, rarely is it the middle of the wall. It's where you have these products coming together. And this is where the challenge happened. Pre-construction meetings, just want to emphasize the importance of walking through these together, communicate. The pre-construction meeting, it's a great time to discuss the transitions between the different trades, the roof and air barrier installer, the sequencing, the schedule, the who and when. So coordinating between the subs, I can't stress it enough. You can confirm together what trades are arriving and engaging on the job site at different times. A little more in depth, we call it, you know, the pre-installation meeting. This is more product specific. If you have questions about the flexible stainless steel transition membranes or flashing installation, we can come and we can review a project specific detail and make sure that you are on the right path with the product and how it's installed. The whole point with this one is getting the manufacturers involved. We can help. Also, I mean, I just did a whole presentation on transitions. If you're doing a mock-up, please include the transitions in the mock-up and test it. So that can really, a little bit of investment and time on the front end can save a lot of issues on the back end. Don't forget the accessories. If you don't have these systems required accessories like the end dams, the corners, the terminations, it can result in a whole system failure. So really good materials can go wrong this way. Don't forget about those. I'm going to summarize and bring it home, and then I can stick around if anyone wants to. I'll put my contact information back up here. I'll summarize this by saying there's a lot of choices out there. I hope that I brought some light to transitions for everyone. Make sure they're not overlooked. Make sure you know where they are, and make sure you have the right products to bring them together. And you can see on the slide, those are the 3 categories that we broke the presentation down into compatibility, the adhesion, and then individual product performance. We can help you with a lot of these things. Lean on your manufacturers. This concludes the AIA presentation. Thank you all for your time this afternoon, or maybe late morning for some of you. Follow us on LinkedIn, sign up for our newsletters. We do a lot of just industry best practices, and you can stay in the loop with what we're doing in the industry. If I reference something today, an article, or you're interested in setting up any further presentations or product reviews, I'm happy to do that. Connect with me, and I'd really love to hear from you all. So with that, I hope everyone has a great rest of the week.
Oh, we
And
do
thank
have
you
a
again
couple
for
of
tuning in.
questions. We have a couple questions, Megan, if you don't mind, we can go through a few of those in the last like 9 minutes. Is that okay?
Sounds good.
We do have quite a few, so I don't think we're going to be able to get to all of them today, but I'll send you a transcript of the questions so you can follow up with anybody who we didn't get to today. All righty. So first, somebody just wants to confirm something that was on one of the slides. On the rusting through wall flashing slide, they want to confirm that galvanized flashing through brick walls is not recommended. Is that correct?
That is 100% correct. And while that's a really great question, so maybe it's on here. Yes. So this QR code, it's almost like I planned that one. It was so perfect there. We have a tab on our website that will take you to industry articles. Choosing the right metal for masonry flashing, we talk about galvanized and aluminum flashing choices in there. And we do quote BIA, which is the Brick Industry Association. And so this is a really good reference. So if whoever asked that, if you want more on it, your answer is right here, and it'll be perfect for you.
All righty. I have someone who is asking if you could clarify what PMMA stands for.
Yeah, that's just a type of roofing chemistry. I don't represent the roofing line on that, so I can certainly. Kayla, I'll get the list of questions here. Okay, cool. Yeah, I'll connect you with someone who can answer all of your PMMA roofing questions.
Okay. Perfect. Next we have, do you have any typical details on your website for what are some good resources to see transitions from below grade blindside waterproofing to the WRB at grade?
Yeah, so we actually, another great timing here. We just added some details for our York 304 SA. So that's the product that whoever asked this question, great question. Thank you for sending it in. That's what I want to direct your attention to. That's our self-adhering product. And let's see if we have our air barrier below grade transition. Let's see if this comes up here. We just started adding some of these in 2D and 3D. So we do have some best practice, at least guidelines for your transitions that will, I think, start you in the right direction. But I would encourage you reach out to me, because some of this stuff with like primers that are recommended and below grade products, like it's always good to know what the tech data sheet is for those specific products. But we do have on our homepage, if you go to York 304 SA, we have a whole list of details that I would encourage you to start with, and then we can go from there.
Great. All right, let's see. What is the name of the perimeter seal flashing receive and clip? Is that something that multiple manufacturers provide where I could use it in a government spec that requires multiple builds, or is it only yours?
Yeah, it's called our AirSeal product. So I would encourage you to look that up. That product was actually created by a consultant in the Washington, D.C. area. They were doing consulting for owners and general contractors and architecture firms, and it was something that they were seeing on almost every job site. So at this point, I hate to say it, but it's pretty proprietary to what what we have right now. There might be a way to work around it, but check this out. It's called AirSill. That's the solution there. And there's the video that I showed.
Awesome. All right, we've got a couple more here. What about end dams at the window openings? Is that needed?
What was I missed the opening of that question, Kayla. Can you repeat that one?
No worries. What about the end dams at window openings? Is that
Yes.
needed? Yeah.
Yeah, so I'm not sure if they're talking about above the window opening end dams, and we do recommend those. We typically say put them at least 6 inches past the top of your opening. I believe the IMI, the International Masonry Institute, says at your, I forget what their wording is on that, of where their location is. It's blanking me, but yes, end dams, and especially if you don't have end dams, things can really go, those little areas can present a big issue. So yes to end dams, and I will follow up with that person with a little more exact terminology on that.
Great. All right. Is there a company that provides the flashing receiver at windowsills, or is that part of a window manufacturer?
Great question. So it is our flashing receiver and clip product. So it's something that York actually provides, but it has been used in conjunction with other window manufacturers.
Good to know. All right. We've got a question and a compliment. This person says, great job. You're always a great reference and leader into the industry. Can you talk about the self-adhering term bar that is compatible with roofing materials?
So I don't know, maybe this person is referring to, we have a self-adhering termination bar called NOBO, which is a termination strip. And this is a new product. One of the things that can happen with your termination bars is they can bow. So we literally call this NOBO. And let me see if I can, yep, in this picture here, you'll see that they can actually bow away from the wall. So this is a product that you can use. It's a direct replacement for your traditional rigid termination bars. It's a 60 mil TPO facer, and it's a butyl adhesive on the back. There's a couple advantages about this in terms of installation as well. Not only the bowing part, but the ability for, you don't need a bunch of people to hold it up against the wall because it's going to adhere. So it'll hold itself there so that you can come back and mechanically fasten it.
Thanks. All right, last one, since we're only 2 minutes left. Does York have any specific products for pre-engineered metal buildings?
It depends. And I'm going to use the most vague answer that I know there. So I think that would depend on the detail and the exact location that they're looking for. But our roots, I will say York's roots are in the masonry industry. And these transition applications have really gotten us into conversations with the roof and below grade and window opening. So very likely that we do. So I'd be interested in talking more about the detail and what, I'm sure they have something in mind if they're asking that question.
Right. Yeah, definitely. Great. Well, Megan will be following up with each of you on those specific questions in a bit. That's all of our time for today. Thank you so much, Megan, for a really great presentation. And thank you everyone else for joining us today. I hope everyone has a great day.
Thanks, Kayla. Thanks to the Acelab team. Appreciate y'all.
Yeah. All right. Bye.